Alright, so I have a new reaction for us to take a look at now. I've talked a little bit about wanting to go to a hydrogen economy, or at least that's what President Bush was suggesting that we do back in the early 2000s. And what we see from this is H2O gas goes to H2 gas plus half of an O2 gas. This would allow us to get hydrogen gas for our hydrogen economy. You may recognize, though, that this delta G that I've got here, 228.59 kilojoules, is a reaction that doesn't suggest that this reaction would like to go forward. In fact, this reaction is very much not spontaneous. So the question is, can I get this reaction to be a spontaneous reaction? Well, it turns out I can. I can tie it to another reaction and use Hess's law in order to get this reaction to be spontaneous. So the second reaction I want to use actually is carbon monoxide gas plus half of an O2 gas molecule will give us carbon dioxide gas. And the delta G for this is equal to negative 257.2 kilojoules. So now if I use Hess's law, I can add reaction 1 to reaction 2. So my reactants are H2O, I'm going to leave off the symbols here, the state symbols, plus carbon monoxide plus half of a O2, and that's going to give us H2 plus half of an O2 plus CO2. And you'll recognize that the half CO2s cancel out. I've got some in the reactants and the products. So my overall reaction here is water plus CO gives me H2 plus CO2. And if I add reactions, remember Hess's law says that I can add their delta H's or delta G's. And if I add the delta G's, I get a value of minus 28.6 kilojoules. So now I have a spontaneous reaction. So, yay, I can now get hydrogen gas in this particular scenario. And actually we do this reaction in order to make hydrogen gas. But what's the problem with doing this reaction? I can see a couple of problems, right? Where are you going to get your carbon monoxide from? Do you really want to be working with carbon monoxide in the first place? Secondly, notice the products. The products contain carbon dioxide, so we still are putting in another fuel, a carbonated fuel, and we're going to be generating a greenhouse gas from this. So it's not a great way to go. So if we're going to do a hydrogen economy, where are we going to get our hydrogen from? Again, the sun contains lots of hydrogen gas, but that hydrogen gas is undergoing a nuclear reaction and it is extremely hot. So we're not going to the sun to get our hydrogen gas. But as we will discover in the redox chemistry that I'm going to bring about in the next section, we will talk about using the sun as energy in order to get this reaction to go. This H2O gas going to H2 gas plus half of an O2 gas. Again, that delta G is not spontaneous, but if I can get enough energy, more than 228.59 kilojoules being negative, then I should be able to get a spontaneous kind of reaction. And the sun is what we're going to do in order to get that reaction to go forward. But that's at another time.